if I say round, because 4.9, if this is 5 or more, it's going to round it up because it's rounding to 2 places. So it changes the 0.49 to 5. If I say round 3, tax, comma 3, then we get the answer that we were looking for, which is 7.495. Okay, so round is very easy to.
Dr. Ubona, why didn't this is Martin, I'm
Yeah.
sorry.
Hey,
Why
Martin.
didn't the round tax 2 print 7.50?
Oh, that's a very good question. I would just have to guess as to an answer. I would guess that when the trailing digit is a 0, it just leaves it off.
So if you wanted to print it, you would have to make it a string again, I guess, or something. If you didn't want 5 blank, but you wanted to see 7.50, you would have to manipulate the variable a little more.
Yeah,
before you displayed it.
yes, that's a good point. I suppose that you would, because it would truncate it. Let's do this. Let's say, yes, you would. You would have to change it into some other type of variable, like a string. Okay, or there are modules that you can use that will automatically format currency correctly. I'm not in a position right now where I can show you that, but if you're doing this in a program, you could import a module that would format the currency in the way of the country that you indicate, and in that case, it would automatically carry over to decimal places. Okay, so that's that. Right, so, okay, let's just do a couple of these, I guess, real quick. Oops. So pull up the shell. Right, so this is integer division, I believe, which lops off the remainder. If you just divide, you're going to get 6.25. Do a division with an odd result, 8.3334. And again, the true value of this would be 3333 forever. Okay, so that's enough for that. Okay, so what else do we have? Let's see. It wouldn't be a bad idea. It wouldn't be a bad idea to play around with this stuff yourself. I'm not going to go through all of these. Notice down here, we get an error because it doesn't know what tax is with an uppercase T. So we're getting a runtime error or an exception, and it tells us runtime errors are pretty user friendly because they generally give you a description of what the problem is. Okay. So what else can we show you? If you're using a Windows, Alt-P, if you're using Windows, Alt-P will walk you back through all of the previous commands in succession. For example, if I do this, can't see, there you go. If I keep doing this, if I say Alt-P, it'll walk back through all of the commands that I previously issued: 25 divided by 3, 25 divided by 4, 25 integer division 4, round, and so forth and so on. This, if you're testing things out in the shell and you get an error, this is a good technique to go back one line and to correct whatever problem that you had in that line. So let's see, with Windows, it's Alt P. With a Mac, it is Command P. And you can just cycle back through all of the previous entries by continuing to press Alt P or Command P until the entry that you want is displayed in the prompt. Okay. So that's pretty much it for numeric.
Jeff, I have a question about Alt P. Are
Okay.
those commands in the shell or is it in your .py file?
Is it in the shell or is it in, what was the other one you mentioned?
Well, your source file, the .py
No, they're in the shell.
shell. Okay,
Yeah.
thank you.
You can use them in the shell to walk back. Another question? Okay. Okay, so that's pretty straightforward. And again, the types of data with numbers really are, the predominant ones are int, which creates an integer variable, and float, which creates a real number. Okay, so what about string variables? Well, string variables are just literals, and you define them within either double quotes or single quotes like this, right? So first name, it's Bob. What is first name? It's Bob. Last name Smith. Can use a single quote instead of the double quote. You can also define an empty string. Just two quote marks together. Notice it prints the single quotes when you do that, as well as with all of the other variables. When you print the value of it, it prints it back with single quotes, not double quotes. But you can use them interchangeably. The value, so why do they have single quotes and double quotes? Well, you might want to have a string within a string. And in order to do that, you have to alternate using either the double on the outside and the single on the inside, as we'll see later, or the other way around. Use single quotes on the outside of the string and then double quotes on the string that's defined on the inside. Okay, so again, all we're doing here is assigning new values to a string variable, and this works basically the same way that it does with numeric variables. Okay, so what about joining strings? There's a couple of ways. Okay, so let's pull this up. We've got this on a script. This is slide 15. And okay, I jazz this up a little bit. So what's going on here, right? So we're creating first name Bob, double quotes, last name Smith. we are joining the strings using plus, using the plus operator in the first example. And again, notice it's kind of cumbersome because last name is already a string, right? So this is a real variable, which is a string variable. Smith, we have to interject this comma as an additional string for this to look nice when it prints out. And then we use another addition operator to join this variable, which is also a string, to this. So this will print Smith, comma, Bob. And then you can also do it with an F string like this, which is a little bit easier. Again, notice we're not using print. We're just creating a new variable called name with an F string. And again, the F string just has one big long string within it. Real variables are entered into that F string using braces, what I call squigglies. You don't have to put more quotation marks to add the comma. And then this first name also is a real variable. So if we run this print statement and this print statement should print the exact same thing. Right, so Smith, Bob, Smith, Bob. What else can we say about this? So we're concatenating or joining the strings. You can do it with either the addition operator, the plus operator, or an F string, as shown in the second set of examples. The F string, the code is a little bit more concise. Okay, so so here we're introducing the string function, and the str function is it's an R native function. And you need to use this in the case of creating a new string that joins string variables with, in this case, numeric variables. Right here, let's pull this up. This is the script from slide 16. So run this. Bob Smith instantiates to this string variable. Age is numeric. It's an integer, instantiates to 40. You can do this two different ways. I have the first technique, the first way to do it commented out. So the F string is, in my opinion, just easier. So we just say, create an F string, name is age years old. In this case, we don't have to use the string variable because we're putting the numeric variable within a string using F, right? So if we run this and then we print the message, it's going to look like this. Bob Smith is 40 years old. If we go back, on the other hand, and we comment out the latter one, and we uncomment the first one, this does the same thing, but note it's just more complicated, more cumbersome. You've got to concatenate several different variables together, at least 1, 2, 3, and 4, introducing new string variables, plus to add the numeric variable to the string itself, you have to additionally apply the string function, which will change age from 40 to a string.